The topic right here is distance on great circles. Remember, I told you the last time that the distance along great circles are distances along the longitude. I mean the the vertical lines running from the North Pole to the South Pole. So let's quickly look at this. I'm going to have to give you a formula here that you're going to use. 2 points P, 32 degrees north, 47 degrees west, and Q, 59 degrees south and 47 degrees west are on the Earth's surface. Calculate the distance between the 2 points. If it takes 14 hours to fly from P to Q, calculate its speed. R is 6,400 kilometers and power is 22/7. So what we need to do now, the first thing is for me to give you the formula to use. If you remember the formula to calculate the length of an arc in mathematics, that is the exact formula we're going to be using here. So let's say distance on great circle equals theta over 360 times 2 pi big R. The R here is the radius of the Earth. You know, we've done that before now. So theta is the difference in latitude. If you're calculating for distance along great circles, you're going to be using latitudes. If you look at this question very well, we have a latitude 59 degrees south and 32 degrees. The two other longitudes are the same, so we don't bother about this. We are actually going to use the latitudes. So the theta here is either the you subtract this or you add them together, as the case may be. Alright, so let's draw our globe. We need to locate this place on the globe. Draw my globe here, just something like this. Okay. Alright, I will locate these places. 32 degrees north, this is my north, this is my south. Okay, so this is 59 degrees south, this is 32 degrees north. Okay, so my longitude now, 47 west. Okay, the same longitude from here. This is my west. So the longitude here is 47 degrees west. So this is my equator. Remember, I need to locate that as well. And then the Greenwich meridian. Don't bother about that. Just okay. I will draw my vertical line, cutting the globe into two. Okay, this is the center here. Now this is my point A. The point P is here. This is point P, where the latitude cuts the longitude. Is my point P. Right here is my point Q. Now what I'm calculating is the distance from the center here. I'll trace this down here. Draw a radius here. Another radius here. So what I'm actually looking for is this distance, the length of an arc. Okay, I'm looking for the length of this arc. Is that okay? So I'm using this formula. Let me go ahead and solve it somewhere around here. So the first thing to do, let me bring this down a little. Just a little more. The first thing to do right here is to find difference in latitude. That is, remember I told you, if they are north and south, you're going to add together. So 59 plus 32, that gives me 91. Okay, now that is my theta, which is my theta. So I'll come over here and say theta over 360 times 2 pi big R is my, okay, that is my distance PQ. PQ. Okay. Now PQ equals 91 over 360 times 2 times 22 over 7 times 6400. Okay, so PQ equals, all right, this got this 2 here 18, 2 here 3 20. Okay, what else? 2 here 9, 2 here 1 6 0. Okay, so 91 times 2 times 22 times 160, that is PQ is equal to 640,640. That is multiplication of everything over here. 9 times 7 is 63. Okay, so if I divide this, I have, what do I have? I have, use my calculator, 10168.89 kilometers. So the distance from here to here is this. Now the second question is calculate its speed. Now speed, as you know, is distance over time. Okay, that is more like physics. So I have the distance here is the whole of this 10168.89 over, remember they gave us the time here. The time is 14 hours over 14. So if I divide this, I have 726.35, approximately 726 kilometers. That is it. Okay, I hope you understand